Welcome back. I hope this morning's discussion spurred some great conversation on break, and I'm confident that the next set of topics will as well. Each day, every day, we're hearing about cyber attacks causing producers around the globe to look for more robust solutions. To protect our customers' critical automation systems against these cyber attacks, we've partnered with Claroty, an industrial IoT security provider. Claroty was founded by Team 8, a cybersecurity think tank that builds new disruptive companies in this space. Here to share his thought leadership on cybersecurity risks and solutions is Team 8's CEO and co-founder. He has a rich career of experience in this space as a former brigadier general of the Israeli Defense Force, now as CEO and co-founder of Team 8, and as well as president of Claroty. Ladies and gentlemen, please help me welcome Nadav Zafrir. Thank you.
Hi, everyone. Good morning. Great to be here, and thanks for having us. I want to start and talk about the hidden risks of cybersecurity. Most of what we're going to be talking about today and the phenomenal things that we've seen so far take the automation part from the maker side. We do have to think a little bit about the breaker side so that we can continue to prosper. We've been at war since mankind has been around. It's just the means and the domains that change. But at the end of the day, we're fighting for resources and other things, and that's probably not going to change in the near future, even with AI and so on and so forth. And specifically, when we think about the IT-OT convergence, we're kind of in this perfect storm. Cross-connectivity between IT and OT, which is what we're here to talk about. This convergence is not only inevitable, but something that we would like to see. And there's no overhaul. I mean, we're not going to take these legacy environments and immediately automatically come up with new capabilities. We have very little visibility, and the threat attack landscape is becoming more and more ubiquitous, and that's some of the stuff that I want to talk to you about. And then finally, of course, we do want to tell you what the hell we're doing about it, or what we're trying to do about it with Rockwell and Claroty. So just let's go back a couple of decades. 20th century is pretty much before connectivity. A lot of us don't remember it. A lot of us are fortunate enough to be born into connectivity. But for my generation, we started before connectivity. And connectivity hit somewhere around 2000 with new technologies that matured at the same time that were actually not designed for connectivity for the general population or for the business world, but came from the military side more than anything else, but matured at the same time. And so global positioning system, mobile devices, packet switching, the internet itself were all designed for human conflict. All of a sudden, they matured, came together, and became available to all of us. And then a few years later, around 2017, we went from connectivity to hyperconnectivity. New technologies came. Of course, our mobile computers emerged in around 2007. Wi-Fi capabilities, and all of a sudden, the world went from connectivity to hyperconnectivity, and the numbers became staggering, and the pace became almost exponential. And if you look at where we are today, we're obviously at the age of cross-connectivity, and that's a lot of what we're talking about today. So cross-connectivity between IT and OT, but also cross-connectivity between infotech and biotech and nanotech, all converging together. And that leads into an amazing, prosperous world if you look at it from the maker's side. And don't get me wrong, I think this is awesome. If you look at our history as Homo sapiens, the only reason that, forgive me for saying it bluntly, but the only reason we really kicked Neanderthals' butts was because we had better connectivity skills. We created language and could abstract collaboration. And maybe 70 to 100,000 years ago, we shared this planet with other sapiens, but we prevailed because we had better connectivity. And that's what we're talking about today. Again, there's always the other side of connectivity. And when you think about convergence of IT and OT, you must remember that these environments, at least in the past few decades, were just not designed to play together. And so as we're creating new automated devices, and as Rockwell leads this space, we already think about security and convergence, but we also have to think about the legacy environments of IT and OT. And OT is insecure by design. Most of the stuff that's now getting connected by design was just not created to be connected. And security was done by two concepts that no longer hold in today's environment. One is isolation. So if it's isolated, nobody could get to it. Why do you need to protect it? The second is obscurity. So security by obscurity. Nobody knows these protocols. They're all proprietary. We've got hundreds of protocols. Nobody understands them. So how are they going to talk to them in the first place, even if they got connected to them? And in many ways, with no common language, we created sort of a Tower of Babel. And it's a mess. And as things get interconnected, whether we want them to get interconnected for productivity, efficiency, effectiveness, and safety, they're also getting more and more fragile. And this is just a glimpse of the Tower of Babel that we're creating, right? This is just, for those of you who are in the industry, you can see, and if you can see, some of these automation protocols. Each one of them has their own 50 shades of gray, if you like. I was told that 50 Shades of Gray for a masculine, mostly audience is not a good metaphor, but you know what I mean. So this is the environment that we live in, and what we would like to have is just like in the IT environment, we want visibility all the way from the field devices to the enterprise IT. But in many cases, this is what we get in reality. And the reason is, again, this was not designed to be connected. These protocols are proprietary, they're obscure, based on legacy environments. Some of the people that wrote these codes are literally not with us anymore. But they're still running. And so the question is, what do we do about it? Now, that's one side of the story. To aggravate where we are today, there's an active threat landscape out there. So if you look at the history of the last 10 years, more or less, all the way from Operation Aurora and Stuxnet, fast forward to where we are today, where almost every critical infrastructure is at stake. And not necessarily by state nation players, but in some cases by lesser players that have access to the technologies that states have manufactured with a lot of resources. And so this is the environment that we live in. Let's go back to 2017 and talk a little bit about NotPetya. First of all, raise of hand for those of you who have not heard of NotPetya. You haven't heard of NotPetya. So almost everybody heard of NotPetya. Let's talk about it a little bit. At the end of the day, quite a devastating attack, by the way, which is not directed at the OT environment, right? NotPetya, to the best of our knowledge, allegedly carried out eventually by the Russians against the Ukraine. Now, the Russians meddling with the Ukrainian environment cyber-wise is not a new phenomena. If you go back to to Christmas of 2015, Christmas of 2016, the lights went out in the Ukraine. 2015, they take out the actual production, and then 2016, the grid goes down. Very sophisticated attacks, by the way. The operational art behind these attacks is quite impressive. And remember that the smart part in most of these devastating attacks that we see is not at the front line. It's not at the malware level, but rather the puppet master in the background that has the ability to collect information, now that everything is connected, collect data with a very simple tool at the front line, bring it back home, think about it, analyze the data, decide on the next step, and so on and so forth. The interesting thing about NotPetya is at the end of the day, it took down large industrial conglomerates around the world, from Maersk, largest shipping company in the world, to Merck, to European FedEx, Saint-Gobain, which is a huge French producer of building environments, and so on and so forth. At the end of the day, this attack on the Ukraine in Kiev means that ships in the port in LA cannot move. So let's think about it a little bit in order to understand the complexity of these kinds of attacks. So there are two different exploits that are used in these attacks. None of these exploits are actually designed, researched, and written by the actual attackers that took down the Ukraine through MEDOC, which is a software that's used sort of like the Ukrainian version of TurboTax. So anybody operating within the Ukraine mostly uses MEDOCs as their software. That was sort of patient zero, where they piggybacked on that to penetrate, propagate, and finally take down a lot of organizations. The malwares themselves, though, the first one, which is used for the penetration, is called Eternal Blue, leaks from the NSA. Couldn't be higher state-level capability than that. And that leaks, unfortunately, from the NSA. And the malware that's used to propagate is called Mimikatz, which has been around for a while. The first one takes advantage of, in this case, unpatched Microsoft software capability. And Mimikatz originates a few years back and allows you to propagate. Now let's think about it. Maersk, Saint-Gobain, FedEx, and others had nothing to do with this quarrel between the Russians and the Ukrainians. They were innocent bystanders. And in this case, what we see is that IT takes down OT operations. By the way, leading to shutdowns of ships, manufacturing sites in Europe, hospitals, including in the US. So this is sort of the complexity of the situation, and we see the convergence and the complexity, and we see nation-state and non-nation-state, and how this sort of exemplifies the complexity of the world that we live in right now. Now, fast forward to August 2017, now we see an attack that's directed specifically against a very critical manufacturing site in Saudi Arabia, in this case, Saudi Aramco. Specifically, it goes out the SIS system, the security systems of Saudi Aramco, in this case, Tritonics, which is manufactured by Schneider Electric, but it could have been any other manufacturer, to be honest. And specifically, to the best of our knowledge, and many researchers have gone through what happened here, including our own research team in Claroty, what we understand is that they were not going after what eventually happened, which is a shutdown, but rather what we'd like to call a red button, which is even scarier. A red button meaning we have a capability, we make use of that capability when we want to. All right, so they were trying to get into this system, get a foothold in Saudi Aramco's environment, and then carry out the actual attack when they felt was the right time for them. So at the end of the day, they messed up. The malware went out before it was supposed to, and the Triconic system actually did what it was supposed to do. It shut down. But if you look, we believe that this is just the tip of the iceberg in terms of what is going to happen. And in the very short history of cyber attacks, let's say of the last 20 years, what we've seen is every time a state actor, and in this case, the alleged attacker are the Iranians, and some claim that the Russians helped them out. And again, this is a political quarrel between two nation states. And again, we see a business, in this case, probably one of the biggest businesses in the world, getting hit by this attack. And it's not the first time that Saudi Aramco takes a hit. The first one was a few years earlier on the IT environment. This is the first one that we see specifically going for the OT environment. The bad news is every time we see an audacious, bold attack like that, what we see a few years later or a few months later, we see the copycats. And these are not necessarily nation states. They could use the same capabilities. Oh, this is a good idea. Let's go after SIS networks, and now let's use it for ransomware. Because these mix and match is happening all the time on the criminal side of cyber attacks. And this is something that we should be aware of. And so what we usually do in these kinds of attacks at Claroty is that we try to get the malware, which we did in this case. We take it into our lab. we reverse engineer it, start looking and try to anticipate what are the copycats going to do, what are the criminals going to do. Okay, so if the perpetrators in this case use this kind of attack vector, what other 6 attack vectors can we anticipate? Because at the end of the day, cybersecurity is a learning competition. And we're only going to win this competition if we're a little bit ahead of the curve, which, to be honest, I don't think we're doing a good enough job right now. And these attacks are just examples of what's going on. So what do we do about it? How do we fix it? So a few years ago, we've taken upon ourselves at Claroty to really go out and identify what is the heart of the problem. And in our opinion, the heart of the problem is this Tower of Babel. So Rockwell Automation is the leader. Of course, there are competitors in the US and in other places around the world. Each one of them has their own protocols. Some of them are newish and have taken into consideration the fact that cyber is an issue. The legacy ones haven't. Most of them are not publicized. They're proprietary and are not shared with the world, so it's very hard to get that visibility that I was talking about. And if you can't see, how can you protect? So the first thing that we did was we decided we are actually going to go and buy all this equipment, look at these protocols, and do what we call a blind protocol analysis. That means we're going to try to discern what these protocols mean and how they operate and what their makers designed them to do, so that we can get visibility to all these protocols, literally all these protocols, and we're down to about 95%. So now we can get the info, the data, we can do deep packet inspection and create a baseline, because as was said before me, remember, these are not necessarily human-machine environments. These are repetitive, automated environments. And so anomalies, in this case, is something that if we see them, that means something. So if we see something that hasn't happened for the last 90 days, if we see something that should not happen according to the protocol that we know, we can immediately alert. And the idea is not to isolate. The idea is to connect, which is what we're here to talk about. So the idea is to make safer, more secure, more efficient, more effective environments by understanding every protocol on the planet, so we can do a deep packet inspection, create a baseline, and anticipate anything that is going on right now or will happen in the future at a very early stage, so that we can do something about it. Because these attacks, you should understand, are really sophisticated, and they take time. And usually the malware at the front line is just a nimble, very simple collector device. If we can see something is going wrong at that stage, before they have imagined the attackers, the environment, before they were able to propagate to the environment, that's the stage that we can do something about it. And so that's what we're out to do. We are collecting all that information in complex environments. We're doing the DPI, building a profile, looking at the anomalies, and offering our customers a safer, more secure way to interconnect their IT and OT environments and so on and so forth. And the reason that we're here and the reason that we're proud to be here is at the end of the day, it takes a village. And so what Rockwell has done with us over the last couple of years is that they say, well, if you're so confident in your ability, why don't you come into our labs and show us what you can do? And show us that you can actually discern these protocols. And show us that not only you can discern these protocols from different vendors so that we can augment everything to one glass, but also show us that you can do this completely passively. Because for the automation people in the crowd, the last thing that you're going to allow us to do is get inlined in order to collect this information. And so we have to do all this passively, and we've been working with Rockwell extensively over the last couple of years to do that. And we think we're at a point where we actually can do that. And so by bringing together automation vendors and Rockwell at the lead, security technology innovators, and we believe we're at the lead in Claroty, and the actual asset owners, we really believe that we can solve for this connectivity age, and again, promote the prosperity that will come from this connectivity. And so again, we're proud to be a part of this journey, which we believe is not only going to make the world a little bit safer, but it's also going to solve for some of the biggest problems that we see in the future. And so where is the future going, right? What's next? And so, you know, I'm probably not the guy in this crowd to tell you where the future of automation is going, but we all understand that as we get more connected, and this is something that I want to leave you with, we're perpetually expanding the attack surface. And so, in a previous life, before I started Team 8 in around 2014, I led 8200, which is the Israeli version of the NSA. And as the world got hyper-connected, we realized something very cool. We are on the offense side. The attack surface is gradually growing, and somewhere around 2008, it got exponentially bigger, which created just so many more opportunities. That's what it's all about. That's why the attackers are getting the upper hand. Because as this attack surface grows exponentially, there's just so much more code for us to find bugs in. There's so many more connections for us to penetrate in. And what we need to do, and that's what we're determined to do, is find ways to proactively get ahead of the curve so that we can make these connections without creating a fragility that is just unacceptable, especially when we're talking about critical infrastructure. And so when you think about emerging risk and the Internet of Things, let's talk about mobility, right? I think that's probably on everybody's mind. So, you know, we could really do some good if we actually figure out autonomous driving, autonomous grid, all this information coming together. Just as an example, this shocks me every time I say it, but there's more than 1 million people that die every year of car accidents, right? I think 20 years from now, when we look back and think of the fact that we put our children in boxes that go 60 miles an hour and 80 miles an hour with people that we don't know coming in front of us, that was not such a great idea. And there are better ways to do it. But that means interconnectivity, convergence, big data, AI. That means fragility. That means we need to create resilience. And it takes this village to bring everybody together so that we can create this resilience, save these lives, save the emissions, and create not only a safer, but in this case, a much more efficient automation or autonomous driving environment. So that's what I wanted to tell you today. Thank you very much.
Thank you to Nadav and the Team 8 Claroty team.